In this video, we're going to take a look at how you solve limits. We're going to look at the substitution method, and then when that doesn't work, we're going to take a look at how you can use factoring, multiplying by the conjugate, and trigonometry to get a desired result. So let's take a look at our first problem. So when I look at this, there isn't really anything limiting me from essentially just substituting and solving, so that's what I'm going to do. So we have the limit as x approaches 3 of x cubed minus 7x plus 2. And this is basically as simple as substituting. So when you look at this, this is a continuous function right here. There's really nothing restricting the domain. So all you have to do is take 3 here and then substitute it in for each x. So let's do that. So this would be 3 cubed minus 7 times 3 plus 2. All right. So all we have to do now is just simplify. So 3 times 3 is 9. 9 times 3 is 27. Minus 7 times 3 is 21. And then plus 2. And then 27 minus 21 is 6. Plus 2 is equal to 8. So the limit as x approaches 3 of that function is 8. All right. So now we see a restriction on the domain, and let's try to substitute. So we put 5 in for x here and here. That would equal 5 minus 5 over 5 squared minus 25. Okay, so if we look at that, 5 minus 5 is 0. 5 squared is 25. 25 minus 25 is also 0. This is something we do not want to see. This 0 over 0. Undefined. So that's not an answer. But there is an answer. And how we're going to get to that is we're going to use factoring to our advantage. So we have the limit as x approaches 5 of x minus 5 of x squared minus 25. Basically what we're going to do is we're going to find a way to break apart anything in our function in order to cancel. So that's as simple as we know x minus 5 is basically nothing we can do with that. So let's factor this on the bottom, this expression down here, and that's basically perfect squares. So we know that's x minus 5 times x plus 5. And when you look at that, you see up here, we have x minus 5 down here, x minus 5. Everything's being multiplied down here. And it's just one expression on top, so we can cancel. So get rid of that. We'll do that in red. And then we see here, this is basically the limit as x approaches 5 of 1 over x plus 5. And then now we can substitute. So we're going to take this 5 here, plug it into x. That's going to be 1 over 5 plus 5, which equals 1 over 10. And there is your answer to that limit. All right, for this problem, this is where we need to multiply by the conjugate. Because if you plug in 0, watch this. We plug in 0 for x. Up on the top, it really doesn't matter, because then we'll just get the square root of 4 minus 2, right? Or no, it would matter, because look, square root of 4 is 2. And then you plug in 0 on the bottom, so that would equal 0 over 0. And that's not good. Like I said, we do not want that. We want basically the answer. So to put in very simple terms, so we want to put the limit as x approaches 0 of 4 plus x. Whoa, get rid of that. This thing will let me erase. So 4 plus x minus 2 over x. So in a situation like this, what you're going to want to do is you're going to multiply by the conjugate. And the conjugate essentially just is, I'm going to take whatever expression has, a square root on it, and I'm going to try to cancel that. But I'm going to change this sign here. So if it's negative, I'm going to change it to positive. If it's positive, I'm going to change it to negative. So this would be the square root of 4 plus x plus 2. And then whenever you manipulate an expression like this, you have to essentially multiply by 1 without multiplying it by 1. But it would be multiplying it by 1. So what I'm going to do is I'm going to put 4 plus x plus 2 here on the bottom. So all of this is equal to 1. And that's perfect. So that's just going to leave us with the limit as x approaches 0 of, so we have to FOIL this. We have to basically consider this a foiling problem. So x plus 4 times x plus 4, and they're under square roots, so that basically just leaves us with 4 plus x. And then the middle term is going to cancel because we have x plus 4, or 2 times x plus 4 minus 2 times x plus 4. And then we're left with negative 2 times positive 2, which is negative 4. And then on the bottom, we're going to have x times the root of 4 plus x plus 2. And then simplify that out. This negative 4 and 4 cancel. So we're left with the limit as x approaches 0 of x over x times the 4 plus x plus 2. And then something else cancels here, which is really nice. So then we're just left with this expression. The limit as x approaches 0 of 1 over root 4 plus x plus 2. And now we can substitute. We have a 0, and we're going to put that in for x. And that's going to equal 1 over square root of 4 plus 2, which equals 1 over 2 plus 2, which equals 1, 4. So that's how you multiply by the conjugate to get an answer in limits. And then let's look at some trigonometry. So we have this expression, and basically it would come out to be infinity over infinity. Of course, you wouldn't be able to know that unless you saw the graphs of tangent and secant beforehand. So what you're going to want to do is you want to look for a way to get your function in terms of sine and cosine, because that'll make things a lot easier, because if you made it this far in math, you probably know the unit circle, have that memorized, and you should have it memorized because that helps you out a lot. So let's do that. So this would equal the limit as x approaches pi over 2, and then this would expand out. So we have, what is tangent? So tangent is sine of x over cosine. And then secant is 1 over cosine of x. Now this can be simplified. It's going to equal the limit as x approaches pi over 2. And whenever you have two fractions on top of each other, like in this case, you can multiply the top fraction by the reciprocal of the bottom fraction. So let's do that. So we'd have the sine of x over the cosine of x times cosine of x over 1. And then from here, we'll notice that since everything's being multiplied, we can cancel out the cosines, because one is on the top of the fraction and one is on the bottom, which is great. So this means this equals the limit as x approaches pi over 2 of sine of x over 1. So here we can substitute. So this would be the sine of pi over 2, because we're putting pi over 2 for this. And then sine, of course, corresponds to the y value on the unit circle. So that means the sine of x is just basically 1. So 1 over 1, and that equals 1. So what looked like a complicated problem was not that bad. The limit of this is just 1. So keep practicing. I hope this video was helpful, and leave in the comments any questions that you have. And I'll see you guys next time.